Coulomb's law formula application. Problem number 14. The force between two charges is 2 newtons. The distance between the charges is 2 times 10 to the minus 4 meter. If one of the charges is 3 times 10 to the minus 6 coulombs, what is the strength of the other charge? So let me do a data table. Can organize all my data, all the information that was given in the problem, and I can check if all the units are correct. So the force is 2 newtons. The distance, or R, between both charges is 2 times 10 to the minus 4 meter. If one of the charges, Q1, is 3 times 10 to the minus 6 coulombs, what is the strength of the second charge? Now, because we are using Coulomb's law for electric force, the formula is the Coulomb's constant times the product of both charges. Is all the time 2 charges, not 3, 2. Divided by the distance between them square. So my K, or my constant, is 9 times 10 to the 9 Newton meter square over Coulomb square. So since that's the units, and I need to check all the units on my table, they are all aligned with the SI units. So it's okay. You are not going to use the units when you do your substitution in this formula. Gonna get too big, too messy. So just make number substitution. So the force is 2. K is 9 times 10 to the 9. Is a product. Everything is multiplication. 3 times 10 to the minus 6. Q2. And the distance is 2 times 10 to minus 4 is square. Do not forget to square. So now what we are going to do is we're going to solve all these product and this division. Plug in your calculator. So here is 9 EE 9. 9 EE 9 times 3 EE negative 6 equal. All these divided by, open parentheses, because this here is a square. Open parentheses, 2 EE negative 4, close parentheses, and square, equal. So this number is 2 equal 6.75 times 10 to 11 power. Positive. Q2. So now we are going to divide both terms by this. 6.75 times 10 to 11 power. 6.75 times 10 to 11 power. Those two cancel. And Q2 is the division between 2 and this number. Now, I'm going to do something. Because this number, which is in my calculator right now, is on the denominator, I can use this key to bring this number to the top, to the numerator, times 2. So let's see what happened. Inverse times 2. So that will give me 2.96. I can stop right there. Times 10 to the minus 12 coulombs. So that is my result. Now, if you didn't want to do what I just did, and you want to go ahead and do 2 divided by 6.75 EE to the 11 power, that's how you do 6.75 EE to 11, you give the same result. I'm just showing an alternative that you can use this key, but if you don't want to do, it's fine. That's the final answer. Test review for electrostatic. Problem number 1. 2 electrons are separated by a distance of 3 times 10 to the minus 6 meter. What are the magnitude and direction of the electrostatic forces each exerts on each other? So, a couple of clarification here. There are 2 electrostatic forces acting on both electrons. So here we have one charge, and that's the other charge. So this is the electron. We are going to label key 1, charge of the electron 1, and this is charge of the second electron. So there is a force of repulsion between them because they have the same charge. That will be this force right here and this force right here. Now both forces are equal in magnitude, and that's why the problem is referring to plural electrostatic forces. There are 2 and they have the same magnitude, so we can calculate just one force. Okay, so to do that, we are going to make a data table to collect all our data. So 2 electrons, so the charge of 1 electron is 1.6 times 10 to the minus 19 coulombs. That's the charge of 1 electron. The charge of the second electron is exactly the same, 1.6 times 10 to the minus 19 coulombs. I could just write once, but I want to show you something. And the distance between both electrons, or R, is 3 times 10 to the minus 6 meter. And is asking the magnitude of the force between them. Okay, so we are using Coulomb's law or electrostatic force formula, K, Q1, Q2, over the distance between them square. So our K is 9 times 10 to the 9 Newton meter square over Coulomb square. So that's the unit. So the force is equal to 9 times 10 to the 9 times here. So it's important that you understand when you are pressing the key on your calculator, you need to press the multiplication key. So both are the same. If you both are the same, it makes sense that I write just one time in a square. Divided by the distance, which is 3 times 10 to the minus 6 square. Now we are using our calculator to plug all these numbers and get the result using the proper key. So 9 times 10 to the 9, use EE to the 9, times, open parenthesis, 1.6 EE, negative 19, close parenthesis, square, equal, divided by, open parenthesis, 3 EE, negative 6, close parenthesis, square, equal. So this is 2 times 5, 6, times 10 to minus 17 newtons. Now, please notice you can play back the video that I was pressing enter every time that I finish an operation, just to make sure that your calculator understands that's the final process. Now, we have here 4 options. We know that one of those two, 1 or 2, because that matches with the value that we just calculated. But there is the second part, away from each other or towards each other. Well, since electrons are negatively charged and we have 2 electrons here, so there is a repulsive force. The force is repulsive, and so it should be away from each other. So that is the right answer.